This video shows how to identify transformations of quadratics written in standard form and vertex form. Our parent function is y equals x squared, and there are three types of transformations that apply to quadratics. We have translations. It's a moving left or right or up or down, and this is determined by the vertex coordinates. A reflection, which is a flip about a line, and a dilation, which is a shrink or stretch. Okay? Both of these are determined by A. So let's get a little more detail. Your translations are determined by your vertex point. Your x and y. If the x coordinate of the vertex is positive, so if x is positive, the graph shifts right. So it goes to the right. If x is negative, the graph shifts left. The y-coordinate determines if the graph shifts up or down. So if the y-coordinate is positive, the graph shifts up. If it's negative, the graph shifts down. And this is done by the vertex. It's affected by the vertex. So that's a translation. A reflection is determined by the sign of A. So just the sign of A, not the numeric value of A, just the sign. So if the A is negative, so negative A equals a reflection. Okay. Our last transformation is a dilation. This one is a little different because a lot of people try to include the sign. We just look at the actual number, the absolute value. So the absolute value of A determines if it's a shrink or a stretch. So if the absolute value of A is greater than 1, we have what we call a stretch. And this means that our graph gets smaller. If the absolute value of A is less than 1, we have a shrink. So our graph will get wider. So we have shrinks and stretches. So let's do a few examples. So our first example is going to be y equals 4x squared. So let's get, this is in standard form. So we're going to do A, B, C. Well, our A value here is going to be 4. There is no x term, so B is 0, and our constant term would also be 0. So the first thing we notice that the A value is greater than 1, so that automatically tells us that we have a stretch. A equal 4 means we have a stretch. If we find the coordinates of the vertex, because it's in standard form, we can use the formula x equals negative b over 2a, just like we've done before, to find the x coordinate of the vertex. Well, b is 0 over 2 times 4, which would just equal 0. That's the x coordinate of the vertex. And if we want to get the y coordinate of the vertex, plug it into the original equation, so y equals 4 times 0 squared, which equals 0. So that's the y coordinate. So the graph actually did not move left or right, nor did it move up or down. It stayed on that origin point. So the only thing the graph did was stretch. Let's do another one. We're going to do the equation y equals x squared minus 5, still in standard form. So let's identify A, B, and C. Our A value here is 1. There is no X term, so B is 0. And our C is negative 5. So because A equal 1, we didn't have a shrink or a stretch. It stays the same. But let's find our vertex coordinates to determine if it's going to move left or right, up or down. So if I do negative B over 2A, that's going to be 0 over 2 times 1, which equals 0. So the X coordinate stayed the same. Let's find the Y coordinate. So we're going to substitute into that original equation, 0 squared minus 5, which is going to equal a negative 5. That's our Y coordinate. So we see the vertex point from this graph, and the parent graph is different. This one is 0, negative 5. So that Y coordinate actually changed. So this tells us because it's negative, the graph shifts down 5 units. Had it been positive, it would have shifted up 5 units. We also don't have a reflection because the A value was not negative. Let's do one more in standard form. So we're going to look at transformations for y equals negative 1/2 x squared minus 5. Well, the first thing we notice is that there's a negative sign. So we know there's going to be a reflection because of the negative. So let's go ahead and identify A, B, and C. Well, A is negative 1/2. B is 0. And C is negative 5. So we identified there's going to be a reflection. Let's see if we have a shrink or a stretch. Well, if we take the absolute value of negative 1/2, that's a positive 1/2, which is less than 1. So we have a shrink. Next, let's find our vertex coordinates. So we're going to use negative b over 2a to find the x coordinate of the vertex. So that's going to be 0 over 2 times negative 1/2, which equals 0. So the x coordinate didn't change from the parent function. Find the y coordinate by substituting into the original equation. So that's 0 minus 5, which is negative 5. That's the y coordinate. So the graph, based on the vertex, the graph shifted down 5 units because of that y coordinate of the vertex. It shifted down 5 units. Let's do a few of them in vertex form. This will be a little faster. So for example, if we graphed, or if we're looking at the equation, y equals x plus 3 squared. Well, let's get a, h, and k. So a is going to be equal to 1. H is negative 3. We don't have anything in the back, so k is 0. So A is 1, so there wasn't a shrink or a stretch, and it wasn't negative, so no reflection. H is the x coordinate of the vertex, and K is the y coordinate of the vertex. So this tells us that the graph shifted left 3. And the y coordinate is 0, so it didn't move up or down. So that one was simple. Let's try another one. What if we have y equals x minus 1 squared plus 3? Same thing, get your a, h, k. A is 1, h is 1, k is 3. So a stayed as positive 1, so no shrink, stretch, or reflection, but our h value is 1. And k is 3. So this shows us that the graph went up 1 unit and, sorry, it didn't go up 1 unit. It shifted right 1 unit. So right 1. It shifted up 3 because up is determined by the y coordinate. Last example here. We're going to do y equals -3, x minus 2 squared plus 5. A this time is -3. H is +2. K is +5. Because we have this negative, we know it's a reflection, so we know we're going to reflect. If we do the absolute value of A, it's going to equal 3, which is greater than 1, so we'll have a stretch. H and K we have 2 and 5, so that means our graph moved right 2 and up 5. Okay, that's all. Thanks for watching.